Okay, on to the next topic. We're going to start discussing matter. And before we start talking about matter, because matter is really what is the foundation of chemistry, we need to talk about how matter and energy have relationships to one another. Matter is simply anything that has mass and takes up space. There are things that are pure substance, things that have just one thing in them. That can be an element or a compound. And then we have things that are known as mixtures. Mixtures are two or more substances that are put together. Like if you put sugar in your lemonade, then that would be something that's a mixture. If that sugar fully dissolves and looks like you can see straight through it, that's usually what we refer to as a homogeneous mixture. So it's got one state in there. Salt water would be another example. A heterogeneous mixture is something that's not the same throughout. This is something that you usually can't see through, or it's murky or something like that, or it could be as distinct as like sand and water. Italian dressing would be one of those things that would be a heterogeneous mixture. When you shake that up, it doesn't all mix together. I think everybody's heard of the different states of matter being solid, liquid, and gas. Solid, if you think of water, you can think of ice. Liquid's what you usually drink, and a gas would be like water vapor, so that's stuff that you are breathing. You are constantly surrounded by matter, whether you know it or not. And another thing that we tend to classify, and you've probably done this from early age, is the difference between physical changes and chemical changes. This might sound easy. Believe it or not, this is actually one of the more complicated things that can be thrown at you at this point. Physical changes are meant to be different states of matter changes, such as a section of water going from vapor to liquid to ice. That's what that's meant to be as a physical change. Versus a chemical change is where a chemical has reacted with another chemical and has actually changed. But if you think about certain things like frying an egg is actually a chemical change and not a physical change. And the reason why is that that egg's chemical composition is changing with the heat. It's not that it's solidifying and not changing, okay? So you gotta be careful with those a little bit. When we deal with energy, we have to talk about temperature. There are three major measurements for temperature, that being in Fahrenheit, which you're probably most familiar with in the US. Celsius was what most of the rest of the world uses, and then Kelvin. Kelvin is set so that 0 Kelvin is thought to be absolute zero, or the temperature in which everything in the entire universe is theorized to stop having movement. So if you think of it that way, temperature is kind of like the average energy that's going on. So movement of molecules is what temperature kind of is. And we can relate these things to each other. Fahrenheit is 9/5 Celsius plus 32. Another way to look at this is 1.8. These are exact conversions, so you don't have to worry about significant figures here, okay? Kelvin is equal to the degrees Celsius plus 273.15. So 0 Kelvin is whatever you have in Celsius minus 273.15. That's pretty cool, people, okay? So let's start with the problem. If you've got 98.6 degrees Fahrenheit, what is this in degrees Celsius? Remember, you've got 98.6, you subtract the 32 from each side, multiply by 5/9. Remember how you have to reverse this from both sides? Okay. You could also say that this is 1/8. You can divide by 1/8. That is the exact same thing. It should give you the exact same answer. So my answer is 37. I started with 3 sig figs. I should give the answer in 3 sig figs as well. Excuse me. We can also convert this to Kelvin. So Kelvin would be 37 degrees plus 273.15. That's going to be 310.15, but with the right number of significant figures, Since this is an addition problem, we would do that to the tenths, and that would be the 0.2. Okay. I doubt somebody's going to come into the ER and ask you all if you're okay with a Kelvin temperature. However, if somebody's from another country, it's very common that they would come in and tell you their degrees in Celsius. Okay, thank you.